So the work on the Scared Stiff continues. We cleaned out the motor, got the spider motor going again. Done the work on the soundboard, replacing some of those caps, those on the AV board. And now we're gonna fix this hack that was put in place with these two capacitors in C42 and C28 that's just been hacked in, stuck to the board with glue, which is gonna be interesting to see how we get that off. So the other thing we're going to fix is on the main driver board, they have in fact just soldered on, instead of using the regular connectors, they just soldered on wires onto the board and then use connectors onto a connector to connect those wires, which is just nuts. So I'm going to be doing those two things today, fixing up those two hacks, which is literally replacing those two caps, getting them off the board, getting rid of all the gunk that's stuck on there, putting back the header pins in there and remolexing this wire here. So you can see here, so on J114, J141, you can see literally they've just soldered the wires directly onto the board and then have this connector, which is just nuts. So that's the one thing, just close up. And then the second is that great hack there that we're going to fix. So I'm going to get these boards out, we'll get it on the bench, and let's try to clean this board up and fix the hacks that have been done on this. So we've got the boards out. You can now see the detail of this hack where they've literally just stuck on two capacitors. I don't even know if they're the right capacitors, to be honest. It might have an impact on the quality of the sound, but they've literally just stuck those on. Not quite sure how I'm going to get those off. I don't want to damage anything. I might use some heat or something, but get those off to start with. And then I've got based on the manual, the two capacitors, C29 and C42 are a 150 microfarad, 160 volt capacitor, which is just going to slip in there. Again, whenever I do capacitors, I know this is boring, but you've got to get the polarity right on these. So you can see the stripe down the one leg, that indicates the negative leg. Also, generally speaking, the longer leg is the positive leg. So anode, cathode, negative. So there's a couple of ways of looking at it. And then on the board, you'll see it'll actually indicate which is the positive, which leg is the anode, which goes in. So I'm gonna have a look through that now. Try to see if I can get this off. I'm not quite sure how that's gonna work. So that's that. And then second, this is this great hack job where they've literally just soldered the wires onto this. I've never replaced header pins before. Got my box of goodies. So this is the 0.15 header pins, and you just literally go through and cut it. So I've never done this before, so we're gonna do that, but I'm gonna start with the other capacitors. So once we put these header pins in, also we'll obviously have to change get the plug, get rid of this Molex plug and put another Molex on the other, a regular Molex on there. So let's start by trying to work out how to get that glue off. Now, I'm just not quite sure what's the best way. So you can see there's a really good lump of glue underneath each of those. So I'm gonna just try and see what I can do. Hopeful that I can maybe pry it off on the inside underneath between the glue and the capacitor rather than the glue in the board. There we go, that's just popped off. So that's literally, but it's just pulling off some of the, so that's the one side, the cap. This glue is just really crazy that they've used. So I'm going to try and use, I've got one of these little tools, which is a remnants from a kit that I used for replacing an iPad screen many years ago. I'm just trying to leverage this between the the glue and the capacitor, rather than trying to pull the glue off the board at this stage. God, what a bloody ridiculous state of affairs. There's a little bit of leverage there. If I can just break the bond between the capacitor and the glue on a number of sides, slowly but surely I'm hopeful that I can wiggle it off without it damaging the board. There we go. I mean, that is just the most horrendous thing. So now I'm just trying to get under the glue with ease and trying to get that off without damaging the board too much. It looks like just some kind of epoxy glue as well. It's not exactly the easiest glue either. Actually, there we go, that's not too bad. Okay. It's kind of like a mixture of epoxy and a silicone. They've gone over some of these components. So I'm going to try to use this. This is an X-Acto knife, which has got like comes with like a chisel blade, and it seems to be pretty effective at getting it off actually. So it literally goes on the circuit board, and it doesn't seem to be damaging it there. Literally just cuts through it. It's just pretty effective. So this will take me another 5 minutes, and then the silicone will be gone. But it really is quite an effective way of getting it off. I doubt anyone's going to be in this position in the future, but nevertheless, if you ever wanted to get silicone off of a circuit board, a X-Acto knife with a little chisel end on it works a treat. Who would have thought? It took me about 3 or 4 minutes. I've cleaned it all off. It's by and large, it's all gone. I'm just going to give it a final clean with this. It's just a circuit board cleaner, generally designed for removing flux and things, but I just know that it's not going to damage the board, so give that a bit of a wipe, and then just a brush to get rid of any of the residual, if there's any gunk left behind, and then I'll just wipe it off with this, and nice clean space where that gunk was. Now you can see nothing left. A couple of scrapes where things come up. So I'm going to remove these 2 wires on each case where they were basically hacked into place. So just cut those off. So those hacks are now removed. I've got the correct products here, so I am going to clean these up and put these back. I'm going to start by just adding a little bit of extra solder to each of the joints. I'm hopeful that that's going to make the removal of the solder much easier. Bit of extra fresh solder with a bit of fresh flux in on each of the holes we're looking to remove. Let's go to the underside. There's 2 capacitor holes. that one done. And these two. It looks like the tracks may have been damaged when this was originally done. And so then try to repair the tracks on here by flowing solder across. So we might have to do a bit of that. Normally you've got a nice component pin that's coming through that you can aim at, and you can center your tip of your desoldering iron on, and then it just wiggles around on it. Given that there's nothing to center it on, it's a bit more tricky. But we'll get there. Okay, so on this one, the holes are good enough to go through. You can see the anode on this side, it's a little plus sign. The negative obviously goes on that side, so the negative is the light leg, as I said, with a little band down it. That is able to flow through nicely there, so no problem there. That fits through perfectly. So we'll take that out. This one, on the other hand, there's a bit of an issue here, so I'm going to put a little bit more solder on this one and then suck it out again. Fresh solder and flux. So I think I've made a bit of a mistake by cutting those wires off. I've got nothing to hold on to it. What I should have done, I think, is when I had the wires on the end of the old capacitors, heated them up one by one and just removed them. I think that would have been a much better way of doing it. Now I've got these short strands of wires on this one which are blocking things up. So I'm going to try and poke it through with a hot leg of one of these capacitors. Okay, that was a bit tricky and a bit messy. Moral of the story is when you're removing the wires, don't cut them off. It might be easier to pull the wires out from when they're still attached, but obviously wait for them to get heated up. Okay, so I'm going to pop these in now. Positive leg is going the longer leg, negative leg, shorter leg, and the one with the stripe down is going in the negative side. So using the polarity that's on the board to get that in, making sure that we check that, bending those legs out a little bit, doing the same, positive leg, negative leg. There's no point in not being paranoid enough here. Negative leg going on this side, positive leg going on that side, and just getting those through there. And now I'm just going to go and solder those on quickly, and we should be in business with the audio-visual board. Let's just get a nice clean tip. Get a little bit of extra solder on the trace here. And the same on this side where the trace is just a little bit damaged. So that's not some of my finest soldering of all time. I've had to repair some of the traces that were a bit damaged, which might have been the reason why they hacked the job with the wire in the first place. Now, one of the things I want to try to do is to make sure that we can just do a quick continuity check. So I want to make sure that there's no cross continuity between the two legs, just because there are a lot of wires going across, and little strands of wire could easily have been gone through. So then just check that there's continuity between the various points where these capacitor leads go to. These are just grounds. So that's good. That looks much neater and cleaner and tidier. Hack job done. Fixed up. So that really is significantly better than what was before. Now I'll move on to the other board and then see how we move on from there. Okay, so we're moving on to repairing the this hack job that's on the transistor board, main transistor boards. So I've learnt my lesson this time. I'm not going to cut those wires off. I'm going to heat it from the bottom and then pull those through. That way I won't get messing around with strands, and I'm hopeful that it's a lot easier than the last time I did this. Just be careful, I don't want to damage the traces. So just letting the solder really become liquid before I pull. This one seems a bit tricky. Let's have a look what it looks like on the other side. Okay, let's add a bit of solder, see if that helps. It's quite funny, it's counterintuitive that you add solder to remove solder, but the fresh solder can really help. And we'll suck it out later. So the fresh solder's new flux provides better connectivity. It means that the whole, that's just my multimeter heating up. So with the new solder added, it just seems the heat transfer is a lot better. And there we go. So that's the wires pulled out. Now you can either just use a standard solder sucker to get that out. I'm going to add just a little bit of adding that little bit of solder really helped get that out. Unfortunately, the solder sucker that I have is just a little bit cheap and nasty, so it takes a while to heat up. So while I'm waiting for the solder sucker to heat up for that, I'm going to get the header pins out. 1, 2, 3, 4 pins, and I'm just using a pair of side cutters, and that just cuts off there. This will go in from the other side, and then the pins will solder in. Again, I've never done header pins before. Okay, solder sucker's ready. So you can see I've got a nice clean set of holes now. This goes in from this side. Let's see if that fits in nicely, look at that. And really is as simple as that, just fitting it in there. My OCD between the black and the white header pins is going to bother me, but I'll get over it. Now I've got one of these really cool little things that helps me solder. One of these extra bit of hands which I can use to hold the header pin in place whilst I solder it in place. So before I do, I'm just going to show you this really cool little thing that I've got for soldering. It's just this little gadget. It's got a bit of a heavy base and then all these little arms. Because so often when you're looking to solder something, you need an extra pair of hands. So in this case, where I've got the header pin in there, and I'm looking to, let me just turn that to the side so that you can actually see what I'm doing. So it's not overexposed. Okay, so I want to just hold that in place whilst my other two hands are soldering. I've just got to get one pin soldered nicely. So that can go like that. Now I don't have a problem with holding it. One hand for the solder, one hand for my soldering iron. And it just makes the job a whole lot easier. So once you've got one in, it's held in place. So just need to get the first header pin in. Once your first header pin's in, you can remove this. Oh, that's hot. Another reason why you don't want to hold it. And let's just solder the others in now. That's beautiful. I'm just going to, again, me being a bit paranoid, just make sure that there's no continuity across these. Okay, so just checking that. Now, I'll then just clean the flux off with this again. Just got a little spray of this. This helps get rid of that flux. And a bit of plastic old brush. Just you can use an old toothbrush. Just gets rid of all the flux. And that is my first header pin solder and replacement. So no more hack job. Again, I'll now go and just replace that plug on the other side, and we don't need to do anything. What I will do though is I'm going to go and just confirm which is the lead, which is the key. And I'm going to do that inside in the manual quickly, because you want to cut off one of the header pin. I believe that it's going to be the one which is marked. If you look on the board, there's a little straight line which I think is where the key is on each of these. So if I look across here on this header pin here, for example, that's where the little dot is, and so I'm going to go and cut off one of those, and then I'll put the key in the plug. That just ensures that you don't get the wrong plug in the wrong hole, although that it does look like J140 and 141 have got the same setup, which is weird. Now I wonder if that's just because the circuitry is the same, and we can easily confirm that if there's continuity between So it's interesting. So between J140 and 141, basically pins 2, 3, and 4 have continuity between them. So what that means is it doesn't actually matter when you're plugging in your plug whether it goes into J140 or 141, they're interchangeable. Hence the reason why they're actually the same. Whereas in cases where it's not applicable, the key obviously is obviously much more significant. But I'm going to just go and check that in the manual that it is in fact that this pin gets cut off and will create the thing. But pretty happy with that. That was pretty easy. Didn't think it would be hard, but again, if I can do this, anyone can. let's get going and get this back in the machine, and we would have cleaned this board up a little bit more. So there's the driver board page. You can see it's on page, what is it, section 2, page 7. So if we zoom in now, so we can see and I've lined it up, and you can see that here's plug 141, plug 141, and you can see pin 1, it's got a little star on it and the other 3 circles. That indicates that's where the key is, which also coincides with where these stripes are. And you can see that on 140 and the like. So what you want to do is you want to cut off pin 1, because that's where it is. So to do that, I've used a much heavier set of pliers, and that's the end of that. So you can see pin 1 having been cut off there, which is the same as the plug next to it, which I said, showed you is both of these look like they're interchangeable based on the schematics and checking that continuity. So we'll go now and make the plug for that. Got my little box of Molex plugs and connectors. This is the, as I said, the 0.156 inch. I'm sure there's a fractional version of that, but 0.156 plugs. I'm going to need a 4 plug, which I have plenty of, and we'll go and do that in the plug. If you want to see how to do that, I've got another video which goes through how to make a Molex plug and connectors. I'm not going to show you how to do that here, but the one thing that I thought I'd just share, I'm not going to show how to do the actual Molex cables, but I'm now done. But just, you'll find at the back of your manual, this is in section 3, you'll see a breakdown of each plug. So here we are, we're doing plug 141, so we've got the key in the first J141.1, we've got the grey yellow, grey black, and plug connector 4 on the plug is not used, so that's no wire there. And you can see, as we discussed, 140 and 141 are identical. So if I now go up and look at the plug that I've put together, so you can see the 2 plugs. This is the new one that I've done, and so 140 and 141 are actually identical in terms of the wirings. That's where the little plug goes in, and you can see the plugs have been put in. Pin 2 is grey yellow and pin 3 black, and the Molex is done in that order with the unused plug with the little key in it in hole number 1, or plug position number 1. So I'm going to get these back in now and turn this machine back on. So we're all good, that's all installed. I've checked all of these. There's no loose wires or extra plugs hanging loose. Oh, there we go. I thought there was one extra here. It's really easy to miss a little plug. Sometimes, what I'll normally do is I actually take a picture of the board close up, and then, because it really is easy to miss a little plug. The other big trick is that the plug gets stuck underneath the board and you don't see it. That's so, again, you just, when you're putting your board in, just check that that's not the case. Same with the ribbon cables. Getting the ribbon cables in is tough. I really struggled with this one. It's very easy to miss a pin. Oh, here we go. As I said, rather just checking all of these. So here we are, this one's labeled 107. Okay. I had a theatre of magic that I was doing some work on, and replaced the transistor. Everything was fine. The flipper coil that had busted. Replaced the transistor, all good, plugged it all back in, and the 2 plugs up here, I can't remember which one it was, but I plugged it into the lower power circuit plug. The one was empty and I just got it into the wrong one. And as a result, when I was flipping the flippers, it was just this very weak, pathetic flip. Couldn't work it out, went back, checked all things, spent about 3 or 4 hours before I went back and just looked at the plugs and just found basically that simple as I just plugged this into the wrong plug. So really interesting. Felt really dumb after. Anyway, so that's all up. Let's see what happens when we flip it. First time. Okay, I'm going to test the sound just because, see if the sound has got any better.
Oh yeah!
I think there's your answer. Just because those new capacitors.
Oh yeah! Oh yeah! Oh yeah!
Now I just need to check what I've done here because I must have caused an issue as this actually powers the motor, so I'm not quite sure what I've done. Problem now solved. Simple things first. You can have a look. I'll turn it back on and you'll see straight away the spinner wheel spins on startup. So on the Scared Stiff, if that doesn't work, you get the error message. So that's now been sorted. All it was really went back and checked the plugs, and the problem was again this ribbon cable that I had a problem with, that I talked about having a problem with. Went back and checked that. Sure enough, had some issues. It was slightly misaligned. It's easy to do. So once you put your boards in, before you start doubting yourself again, go back and just check the plugs. It's so easy to see. You saw 3 or 4 examples now of me screwing that up. Again, it can help you a lot. Look, this video is really pretty unique in that I doubt anyone's going to have these specific issues. Shows you how to put header pins in, shows you how to just replace those capacitors. The audio has definitely improved. Slowly but surely we're getting this game back together. Next step is to replace the Playfield. Going to need to get a replacement Playfield because this one's Playfield's in a pretty bad shape. I've got the ramps, and it'll be my my first Playfield swap, so that'll be a great series. But we've got this game now in full working order. All of the hacks have been removed. Before I do Playfield swap, I wanted to get it in a fully functioning game with the boards working and all the transistors fine, and make sure the plugs and all the hacks have been cleaned up. So pretty happy about that. If you like this video and want to keep track of these changes I'm making, and as I start to work my way through this machine, you can always subscribe. You can push the little bell button so you get notifications when I upload new videos. It gives me some encouragement to keep sharing this content. Again, I've done many things on video for the first time. Most of them are pretty easy and basic to do. Hopefully it encourages others to have a go too. Anyway, that's me. Thanks very much for watching. Until next time.